And with that, we will get started with our presentation. So we're lucky to have Mr. Rob de la Espriella here with us today, former Navy nuclear submarine officer, Deming Prize-winning team member, and pioneering nuclear quality assurance expert. Rob is one of the world's leading experts in solving complex human and organizational problems in the modern work environment. Rob draws from 4 decades of experience in departments of energy and war, the commercial nuclear power sector, and the nuclear weapons complex to offer deep insights into mishap investigations. As the creator of the Blue Dragon framework, he's redefined how organizations solve costly, recurring industrial safety issues. So, Rob, thank you so much for being with us here today. And whenever you're ready.
All right, thank you very much, Matt. Glad to be here. This is my third time presenting to the Long Island chapter of ASSP. I've known Matt for a while now. He was actually in one of our courses at Brookhaven, where I've been to many times. So thank you for the invitation. Very, very glad to be here with you all. So let me get started. We're going to talk about how to approach safety from a proactive standpoint, be quite a bit more proactive, and actually modernize the way we approach safety and how we investigate safety incidents, mishaps. So I have a lot of information to get across. To start with, I want to spend 30 seconds because if I try to read all this, we wouldn't get out of here. But I've been around for over 40 years, 4 decades, starting with Nuclear Navy, the Nuclear Regulatory Commission, the nuclear power plants. And you see the Deming Prize Medal there in the middle. I was on a team from Florida Power and Light that won the Deming in 1989. My job was to be a root cause expert. And I've taken those skills and built on those for the next 3.5 decades. Okay, so enough of that. What we're going to talk about today is 3 things. How we can use something called the bow tie or risk assessment model. And I really love this model for its simplicity. I've enhanced the picture itself to fit my needs. But I'd like to show you how we can use it to our advantage to understand how to be more proactive. And how do we look for systemic problems, not individual events. Next, what about artificial intelligence? How can we harness it to help us out? And I'd like to show you a very recent example of quite a large magnitude to show that when you're looking at large data sets, you just can't do it manually or it would take months. And show you what we've done there. And lastly, having a new modern way of doing business where we can collaborate from many different locations and states and countries even can really help us get further, faster with AI, more accurately with virtual whiteboards. And it's really a whole new era that we've got here. So I want to give you a taste of what that looks like. So I'll start with this. And if you'd like to put something on the chat, I invite you, or if you'd like to really comment, I invite you as well. But how many times have you had issues at any of your organizations, wherever you might work, and there was a mile-wide set of precursors that told you something is going to happen here. It's inevitable. We see so many low-level events, low-level events, low-level events. You know that something big is coming down the pike. And, you know, if you see the image of the Swiss cheese model, you get an idea of how that might work, right? Your defenses in place might stop 99.999% of the issues, but there's that perfect storm where the folks' mindset is not quite right. There's a weakness in the program, the procedures, things line up, and boom, we have a fatality, right? Okay, let's start with what I want to put up on screen here is a price tag. If you don't realize that these recurring incidents are costing us trillions, this is a wake-up call for you, right? We are not able to solve problems the correct way. We keep band-aiding the symptoms. And I'm going to show you some examples that will flabbergast you. Let's talk about the healthcare system in the United States alone. If you'd like to take a guess now, right? Take a quick guess. What will be the cost per year? And this is per the Journal for the American Medical Association. It's, you know, right up there around $850 billion a year, almost $1 trillion. Okay, let's look at the inability to solve recurring issues costing us the cost of poor software quality. What does that cost us? Per another industry group, and it's averaging over $2 trillion a year. recurring issues. Now, how about in our world, in the safety world? Per OSHA, would someone like to throw a price tag on the injuries and fatalities across the United States? And it's the formal way that OSHA does its calculations, right? So this comes straight from their website. I'd love for someone to throw a number on the chat. Just give a wild guess of what you think in that time span, the cost in the United States alone has been. Any guesses? Matt, you want to take a guess? I'll give you the speaking part here, Matt. Give it a shot.
Yeah, I mean, if it's trillions per year just for software, you gotta say, I don't know, let's say 50 trillion. 50 trillion.
Okay. Well, you're thinking in the right, but I look at what people think. People are saying 3 billion, 5 billion. Okay, how about 8 trillion? So you really got to understand the impact. And of course, there's no way to value human life. OSHA tries to put some kind of price tag on it, but we're talking serious impact. And it's not just in the industrial safety arena. It's all over the industries. Think about the price tag for the Department of War and how they waste our taxpayer dollars, right? All right. So it's at a huge cost. And of course, the biggest cost will be the loss of life. Now, here's the thing. We see, and there's plenty of evidence that says we're losing trillions of dollars in recurring systemic problems, and we just don't know how to get after those. And the oversight organizations, and that includes you, a lot of the safety professionals and your security professionals, ES&H, quality assurance, all of these professionals providing oversight, how effective are you? In fact, I decided to draw my own little logo, the mascot for corrective action, preventive action. Are you ready for my fancy new mascot for CAPA? Here it is. It is a horseshoe with a 4-leaf clover with a ladybug on top. That's the kind of luck we need to prevent fatalities in all industries, because we're relying on sheer luck, not that we're actually solving problems. We're finding the root causes of one event. And in many cases, we don't even go that far. We're getting at the symptoms and putting corrective actions against symptoms. Total waste of money and time and resources. Now, so we got to ask ourselves the question, well, what more can we do? All right, that's what we're trying to get to. Well, we can do a lot of things to modernize. How about moving past your static checklists? Something I preach. Checklist, if you're using the same checklist over and over, and it's not dynamic enough to follow the trend of performance, then you might just be checking the box and you're waiting for things to happen to change your behaviors. How about improving your critical thinking skills, your systems thinking? Think of problems as the system is not working for us. What does that maintenance system look like? What does the operation systems look like, right? The system that's involved in creating the desired output. And what about your ability to solve complex problems from an oversight standpoint, from a safety oversight standpoint? Are you really finding the real issues, or are you just circling the bullet holes or just drawing a chalk outline around a dead body? If that's all you're doing, you're not an effective oversight organization. How about focusing on the defenses in place at your place of business? And those are administrative requirements, physical barriers, right? PPE, lead shielding, physical barriers, and cyber controls. So those 3 things form your line of defenses. That should prevent all events. So when an event happens, a whole lot of defenses had to have failed, because there's not one thing that fails. All of these requirements didn't help. All these physical things didn't help. And whatever software or cyber controls, work controls didn't help. So we have to have a defense oversight strategy. And that's what I'm going to do when I bring in the bow tie risk assessment model. And then how about modernizing the way we look at the world through artificial intelligence and how we actually code our problems with some really good trend coding systems and analyze those problems. Okay, so there's a number of things. What does that look like? And so that's what I have to get to. So let's put it all into motion and get into some of the concepts and see what it is that we could do to modernize the way we approach industrial safety. So let's talk about the first one. And I want to come at this from a risk standpoint. If you understand risk, and I can show you a picture, you're going to be much more understanding of what follows, right? How you set in motion certain strategies, because this is what's happening right now. Most organizations and their safety oversight and quality oversight, HS&E, security, They're historians. They're just historians. And they're issuing findings on the first thing they see. Oh, you had an accident. Oh, you didn't stop the accident from happening. Okay, thank you. Thank you very much. I'm going to take that and run with it. So we have to get past this superficial oversight role and get a lot deeper. And this is what I've been building my career on. Stop circling the bullet holes, stop drawing chalk outlines around the dead body, and find out, how did this happen? Why are we here? What failed so that this event could take place? So now let's bring in the bow tie risk assessment model. I love the model. If you look it up online, it doesn't look like this. It's a lot simpler. But if I can show you what we're looking for here, look at the left side, right? If we look at the left side over here, we've got before the events take place. And before the events take place, we have a system in place. And this system is giving us a desired output. This system is allowing failures to take place. Now, we have threats that we've evaluated. And to avert those threats, we actually put in place a whole line of defenses. And we talked about those. Regulations, OSHA regulations, requirements, Code of Federal Regulations, standard operating procedures, all of that. And we have physical barriers, including PPE, and we have cyber controls. All of this is in place to prevent us from having an event. But guess what? These defenses are either weak or not there, or we didn't follow them. The humans bypassed them. And we have events. So now we had an event. Hopefully we're documenting, training, and analyzing. That doesn't always happen. And we're analyzing the defenses and why they failed. We're not always doing that either. And now if you get past the event, we're in the reactive mode. We're over here, totally reactive. And now we are in event response mode. We're trying to do some kind of a graded approach to analyze the event and take corrective actions and prevent recurring events. But because we don't do a good job there, we have recurring events. And overall, how well we do both of these, prevent events and stop recurring events, gives us our total system performance. So if your system is not giving you the performance you're getting, it's giving you the performance you deserve, because that's the way the system is built. You have to analyze the system in order to understand what's broke. That is a key component. So let me just go through some suggestions for you. And you will have these slides, by the way. So we need to learn to talk in systems. This is where systems theory comes in and systems thinking comes in. So your evaluations, your assessments have to be systems based. Now, you have constantly evolving threats and vulnerabilities. They're not static. This is why I don't like static checklists, right? So you should be focusing more on high risk upcoming evolutions, emerging threats and activities. You have to look ahead. The defenses that are designed to stop threats, this is the best way to go about it. Focus on the effectiveness of those defenses you currently have in place. And you do that by comparing performance, looking for those low-level incidents, and going back to, okay, what defenses continue to fail for us, not preventing these low-level events. Eventually, we're going to have a bigger event. So this is a proactive way to focus your resources. Look for the defenses and why they're failing. That's called an analysis of defenses. All right, so now here we have the event, and understand that a whole lot of things in our regulated environments have to have failed. So this is where we are. It's not one thing. It's usually a dozen or 24 things that failed to prevent the event. So we have to determine how they failed. Again, the analysis of defenses. And then we have to cause code everything, document everything, cause code everything, so that we can develop tracking and trending programs that will identify the negative trends, that we can go after the negative trends before they result in a big event, before those causes of the negative trends gives us a bigger event. Okay, now we're past the event, we're in the reactive mode now. So understand that one of the first things we want to do is to make sure we're documenting and cost coding everything. And we can use AI to evaluate the sequence of events, give it a cost code from a very good cost code system, and I have like 6 of them, right? So that we can trend and analyze either monthly or quarterly, and then take action on the results of the analysis. Now, ineffective root causes and corrective actions are going to give you recurring events. So are we tracking the number and significance of events year in, year out, right? And are we putting a dollar amount on the numbers of condition reports, recurring events, year to year? If they're not going down, you're doing something wrong, right? The numbers and the significance year in, year out should be going down gradually if you're truly solving problems. If you have a constant 2,000 condition reports a year, you're not effectively solving problems. You're band-aiding symptoms, right? And to get to the bigger problems, you have to do a thorough, solid root cause analysis. And most organizations are actually figuring out how to write their CAPA programs so that you can avoid doing a root cause, because they're too hot, take too many resources, take too long. You come out with a dictionary report. Nobody likes it. Well, that's not good enough. You still have to do root cause if you truly want to prevent the recurrence of a problem. Someone falls from 10 feet, 10-foot ladder, but they only break a finger. Are you going to do a low-level investigation or treat it like the next time you could die from falling from 10 feet? And we don't. We classify it as, oh, just broke their finger. Let's do some kind of a low-level apparent cause, as opposed to, we don't want this to happen again because next time it could be a fatality. Let's do a root cause. That's a sad state of affairs at most industries. All right, so now, what can we do? Well, this model is going to help us understand that we want to be on the left side of the event. Focus on the effectiveness of those defenses. Treat your problems as a system, right? You're looking for multi-systemic problems, the causes of them. All that might be new language to you, but I suggest you get into systems theory, systems thinking. Okay, and then, of course, the return on investment is going to come from identifying weaknesses and failure points in our defenses and strengthening those, because that's where you're going to prevent hundreds of future events. That's the ROI. That doesn't happen without analysis, right? So now this model is going to help you because it's a living risk assessment tool, right? And it's going to help you craft proactive strategies that will strengthen defenses and improve performance, keep you from happening future events. Okay, very good. So that's what, a 5-minute primer on defenses. Okay, I'm checking my time here. Very good, because I want to spend the last 20 minutes on nothing but whiteboards. Okay, artificial intelligence. Pick your favorite, right? There's all kinds of stuff out there. Wonderful. You have to learn, and when you go through one of my programs, you will learn artificial intelligence, because that is here to stay, the way of the future. And we need to take advantage of these data gold mines. You have a lot of minor issues, document them all. Use AI to tag them with cause codes. Use AI to read through hundreds and thousands of reports, right? Use AI to do multi-tiered Pareto analysis. And if you don't know what Pareto analysis is, you need to learn. It's a great way to do trending and analysis. Multi-tiered Pareto analysis, first tier, second tier, third tier, to get to really, really deep analysis as to what's going on. And I'll show you that right now. So you need AI to do this. And also, we can actually, if you load all your requirements into a data set and put it in AI, AI can very quickly find the broken defenses when you give it the event. We're doing that now. Okay, so very quickly shaving or drastically cutting down the amount of time it takes to analyze the defenses. Very good. Now, here's where I've been wanting to get to, and we're right on time. All right, let's have some fun. Let's take a look at what I've been doing for a few decades. And I'll start with a simple industrial safety incident. Someone's using a miter saw. And if you look here, the incident is, all right, they're cutting wood and the person gets a splinter of wood in the eye. And come to find out, this blade guard had been removed a while ago and never reinstalled. How is it that we're going to look at something like this where the person is using a miter saw without eye protection and without a blade guard? You're going to say, hey, what, Joe, you dummy, make sure when you check the equipment out that it's safe to use, and make sure that you wear eye protection. This is dumb as a rock. These procedure requirements are already there. All right, so now if we put this on a virtual whiteboard and we understand what our equipment requirements are, and we build our timeline, this is what happened to Joe, right? He pulled out a thing, he started using it, he got wood in his eye. We can brainstorm using systems theory. Hey, what is the system in place to keep Joe safe from getting hurt while working with power tools? And we line those out. And guess what? From that systems inventory, we identify the specific requirements. And those are the defenses in place. Well, we have requirements that say you have to have blade guards installed and other safety equipment. We're working with power tools. You have to have requirements for not using power tools for personal use. He violated that. He had to wear eye protection. He must be trained on the safe use of power tools, and so on. All of these defenses failed. All of these requirements are in place to keep someone safe, and they failed. So we ask our lines of inquiry questions. Okay, why is this happening? Why is this happening? What's causing this? Right? So we take the evidence, what happened, we compare it to the requirements, what should have happened, and that is a typical barrier analysis, and we don't want to do that. We want to take that initial deviation and turn it into a question. That is not the cause. That is the initial symptom. And now we want to go and ask the subject matter experts, why are these different? These are all symptoms. These are all things that aren't working the way they should because the defense has failed. So now we take it from phase one, look at the evidence, look at the data, look at the defenses, go to phase two, which is do the cause and effect analysis and talk to the experts and get them to help you with cause and effect analysis until you find out, following through with all these symptoms, where are they leading me to? What is going on? It's not just that, Joe is in a vacuum. Turns out there's not enough supervisors out there reinforcing standards, so the standards have gone by the wayside, right? In the case of wearing eye protection, the supervisors are in their office. There's not enough of them. They're not replacing open positions. They're not out there enforcing rules, and the staff thinks that nobody cares about safety requirements. And that's created a certain problem, right? So this goes to understand why the person got injured. Same thing with all the other ones. So I'm just giving you a sense of go deeper. Don't bite on the fact that they weren't wearing glasses and the blade guard was not installed. I'm just showing you the way we would do this. And once you have these issues identified, you can go to the corrective action phase. Okay. Very quick and dirty, simple example to show you this is a infinitely expandable virtual whiteboard. I can do so many things with this. And I do want to come over here and show you something really quick that I hope you catch on real quick. In my world, there's only two types of investigations. Once you have an investigation, you can either go in two directions. Number one, if you can tolerate 100 more of these, fine, do the rapid apparent causes. But if you don't want it to happen again, if you can't tolerate it from happening again, you must do the full-blown analysis. What I showed you here, the three-phased analysis. And here you can bring in artificial intelligence and take all the time you need, but we're going to make it a lot more efficient. On the left side, it's a quick and dirty. It can be done in 2 hours, 3 hours. And that's what this one is. This one is called a rapid apparent cause. This one could be done in under 2 hours easily. Now, let's go to a different event. Okay, here we are. So imagine you are in a large complex. This happens to be a national science laboratory with PhDs running around. 2 PhDs are working in these cabinets. They come in here to hook up leads routinely. And they used to tag it out, right? They used to tag out the cabinet, open the breaker, tag it out, put in their test leads, and then back off and open the tags. Well, they stopped doing that. They thought, well, it's going to save time if we just do it. So what happens? Okay, here we go. Here's the test leads they're connecting, right? Their hand came too close to this bus bar, and the bus bar arced and caught fire and gave the PhD a shock where he lost sensitivity in his right hand for an hour and a half. This is a shock event. So now, how would you investigate that, right? They really should have had it tagged out. It seems kind of straightforward, right? Now, when you start doing this in a rigorous way, you start identifying all of the things that were involved. The human-machine interface, that's what this section is. This is the equipment, tools, and materials that were used in this section here. You bring in all of the requirements and you look for all of the evidence, the timeline. So let me go through and step here. Number one, gather the performance evidence. And let's take a look. All the gloves, the warning labels, the panels, the bus bars, everything that leads to performance evidence. We did a systems inventory. This is the electrical safety system that should keep people from getting shocked. It includes the CFR, the NFPA requirements, right? Work controls, electrical safety programs. All of these things are required to be in place. They all have procedures. So we start looking for these procedures and bringing in key procedures. And from there, we bring in the line of defenses, right? We capture all of the evidence in timelines. So here's all the timelines of what was going on. Here are the line of defenses in place. And these are very specific from the electrical safety manual. This is exactly what you're supposed to do when testing, measuring, and troubleshooting, right? And this is the question as to why didn't that happen? These defenses were all violated from the electrical safety manual. So this is a very holistic view of the world, right? The systems inventory helps us understand what systems were in place to prevent electrical shocks, and they all failed. Everything failed. So now we bring in the specific requirements that should have been met when working in these live energized panels. First of all, they should not have been energized, right? So here is the analysis of defenses that I spoke about under the bow tie risk assessment model. That's what we mean right here. Analyze the defenses. Analyze the defenses that failed to cause the event. That's how we flush them out. Okay. Now we can look at the CAP database and find out what that's telling us. We can do a twins analysis and look for behavioral analysis. So we bring in behavioral analysis and integrate it. We look at data sets and integrate it. We looked at training modules. These are their 3 training program slides. We analyze those. So phase 1, analyze all the evidence and the data. And in fact, what we're trying to teach you to do is to think like a doctor. What do doctors look for? Symptoms. The symptoms are deficiencies, non-compliance, non-conformance, and it is the symptoms that will lead you to what's really going on. So now we understand how the person got shocked because they didn't follow all of these requirements, not just an individual, as a group. Now we have these questions, right? You notice the questions, the lines of inquiry, we call them. We bring the lines of inquiry here from all over, from the analysis of defenses, from the human-machine interface questions, from the behavioral analysis section, those are brought in, from data sets and other information that we gather. From all that evidence, we generate this robust lines of inquiry. Remember what Einstein said, if I had an hour to solve a problem and my life depended on it, I spend 55 minutes figuring out what questions to ask, and then I could solve it in 5 minutes. That's what we're doing here. So now we ask our lines of inquiry, we bring in the subject matter experts. Now we don't have to do it. We're going to talk to 100 people if that's what it takes. And you notice here, cause and effect analysis. So we go through sequences. And who's heard of the 5 whys, right? Okay, total misnomer. 5 does not apply to humans. 5 is for equipment. 5 is from the 1930s in the automotive industry. Forget the 5. 5 whys doesn't work. This is however many whys it takes to get to the deepest seated root causes. And there's also common cause analysis. I don't know if you can see, okay, the green threads all lead to here. The red threads all lead to here. These are the common causal factors that keep showing up over and over. And we have to keep cause and effect organized until we get to where we can't go any further. Past this point, it's out of the control of the organization. So we keep asking questions as investigators until they run out of answers. And you need to understand, as I said earlier in the slide, you need to understand cause and effect analysis to do this as an oversight individual. And of course, this is a seriously deep, complex issue, not for beginners. But I'll step through real quick. You get the performance evidence, you bring it into phase 1. You understand the system that is in place to prevent shocks. And from there, you develop the defenses that are actually the system, right? The defenses are the procedures, the physical, and the cyber controls, and those are brainstormed from your defenses. Now, you can use AI to look for these from the 10,000 requirements you have in place. AI can quickly find those for you. So there's another use of AI right there. Then you ask unbiased evidence-based questions. The questions can only come from an analysis of the defenses. You can't make it up. And this is so you can stand up in a court of law if there's any fatality or anything like that. This will go to court. Once you have your questions, you bring them down here to cause and effect, and you ask the experts these unbiased, factual, evidence-based questions that they need to answer. How is it that we're here? And we're not trying to blame the individuals. We're looking for deep-seated, latent, organizational, programmatic, and cultural issues. We're not looking for the people to blame, but we're analyzing their behaviors, right? Were they set up to fail? We're analyzing the programs in place, electrical safety, work control, test plan preparation, their training programs. The emergency response also failed. Management control systems, equipment, human-machine interfaces, equipment, tools, and materials. And these are the themes that help us organize the lines of inquiry questions. So you can see how thorough, holistic this is. Now we're getting to some really good answers as to what is really going on. Now, when we fix these things, we take all of these are the deepest seated significant contributing factors, and these are two massively big root causes. Those are what's brought down here to phase 3, the corrective action plans. And now here's the issues. Here's the issue owners. Not only do we put together corrective action plans, we must do a determination as to the extent of damage caused by those root causes and contributors. Nobody does this. It's not enough to address these individual issues. You have to look where else in the organization are these things causing me problems, not just the scientist working on electrical panels. All right. So now you're really getting some huge return on investment by killing hundreds of future industrial safety incidents. And think about it. This is one shock event, and it cost a person numbness in his right hand for an hour and a half. Is there a scenario where the next shock event kills them? Yes. And this would be a precursor event. But if you understand all of the issues and how we got here, and you closed those performance issues, in other words, you strengthened the defenses and you corrected the behaviors, you did whatever the corrective actions are for all of this, you have a huge leg up on preventing future events. That's the return on investment. All right. Very good. Now for a little briefing on artificial intelligence, because I have to give you this big picture. Artificial intelligence is phenomenal for analyzing data sets. Your procedures is a data set. It can find the procedures that were not followed based on the input, the timelines that you put in based on what actually happened, right? AI can look at corrective action program databases really fast. It can look at other self-assessment programs and charts and graphs and trends. It could analyze your training slides. All of this can be done with AI. Makes everything more efficient. Now, AI cannot do facilitation of subject matter experts through cause and effect. AI can't do that. You have to be smart enough to do that and have the facilitation skills to do that and understand cause and effect and the rest that goes with complex problem solving to do that. But if you do that, you're going to be a huge benefit, a huge asset to your organization, because you're not going to be replaced by AI. This is human ingenuity at its best. You have to understand how to guide 100 subject matter experts, or 20 or whatever, depending on the scale of the problem, through a process of cause and effect analysis to get to what's really happening, what's really broken, what really needs to be fixed. Right? Okay, last screen. Let's talk about AI for data analysis specifically. And I mentioned the third bullet was Pareto, multi-tier Pareto analysis. All right. So just to give you an example, in this case, we have a complete nuclear power station with lots of serious issues, including reactor scrams, equipment reliability issues, safety problems. They had everything. This is a complete site assessment. But I don't want to focus in on all these other components that you've already seen me explain, right? Phase 1, all this stuff. I want to focus in on the data set that I analyzed with AI. I had to look at 26,800 rows with condition report descriptions on one Excel spreadsheet. So how long would it take to manually analyze 26,000 condition reports? This is where multi-tiered Pareto analysis is fantastic, comes in handy. All right. So first, I latched on to the codes that I want to trend it by, and info codes are fantastic for that. And most nuclear utilities will all have to use info codes. So now I do my first tier Pareto analysis, and you see here what jumps out at me. These big bars here account for almost 80%, right? Here's the 80% mark of all my issues. So I picked these to go do a second tier analysis. So notice here, this first bar went over to Pareto number 2. So here's the second tier analysis of that first bar, and look what happens. More big hitters jump out. So now that I know, I take each one and I further analyze those. This is the third tier, go even deeper. Guess what I'm using for this? I'm using AI to look at 26,000, give me this first chart. Then I tell it to only focus on these codes and give me the second chart. And then I ask to only focus on the descriptions and the conditions and everything you know about this and prepare a full report. I have a complete report on what is happening, themes, patterns, recommendations, and I have this report hyperlinked here. So anyone on this document can look at it. And this is how I built out all these tier 2 Pareto charts and their corresponding tier 3. Okay? This is called multi-tier Pareto analysis of 26,000 individual conditions. This took me 3 days. It would take 3 months. I don't know how long it would take. Somebody wouldn't even dare to begin to look at that many problems as a whole, right? And this is over a 7-year period, which is this is a gold mine. I call it a gold mine, right? By the way, here's other sets of trending and analysis with different codes. Here's trending and analysis of their key performance indicators, right? Here is the entire analysis of their plant reliability program. Here's an analysis of every single initiative and excellence plan they put together over the course of the last few years. Here's the last few regulatory reports. This is all phase 1 data analysis that AI had a huge hand in helping us with, right? And here's timelines. Here's analysis of defenses. Lines of inquiry came from everywhere. You see the lines of inquiry here in this area. And then through cause and effect, with about 130 SMEs, we ended up with these deep-seated issues that were then rolled over into these corrective action plans. The return on investment from this is in the tens of millions. So it was worth the time invested. How long would it take to do a comprehensive assessment like this? Well, this took 5 weeks, where most organizations wouldn't know where to start. Back to this one. This one took 2 hours. This one took 2 hours. This one took 3 weeks. This one took 5 weeks. You notice what I'm trying to say? The same skills, the same cognitive skills are required. Critical thinking, the gathering, organizing, analyzing of available information is called critical thinking. Using AI to analyze all kinds of data, whether it's Lean Six Sigma tools, Pareto charts, fault trees, process maps, control charts, KPI, all this is data from which we glean performance insights so we can generate questions. The questions go down to phase 2. Analysis of defenses. Look at the defenses that should have prevented the event. Analysis of the human-machine interface. Look at the human-machine interface. Analyze that. Behavioral analysis. Ask why the humans behaved the way they did and make sure that if they were set up to fail. We call it an error likely situation survey. Some folks call it a twins analysis. TWIN. So, and there's all kinds of behavioral analyses out there, culture, climate surveys, things like that. So you understand why the humans did what they did. All of these skills and techniques are built in this one particular framework in this virtual environment powered by AI to be very efficient. And this one, once again, took less than 2 hours. And this is what you should be doing day in, day out, over and over and over for all your little ones. What happens with these? These go into the training and analysis database. And once you do these either monthly or quarterly, which by the way, I'm developing an app that you push a button and it does it for you, multi-tier Pareto analysis. Now you can go after the negative trends with a bigger investigation. And these are very few. The other ones you should be doing a ton. These are very few. Or after an incident, now you're on the reactive side. You have to do it now if you actually had an event. But I'm talking about proactively acting on the small precursor events. That's where you make your money. That's where there is massive return on investment. And now to wrap up, and we'll open it up for questions. I hope you have questions. So I showed you an electrical shock and how we could do it so that we avoid all future shocks. I want to tell you another data point that I got from a different electrical shock event. Imagine a company that's $40 billion. They've been around forever. They have lots of procedures, standard operating procedures. But the root cause that I did found a gaping hole in their programs. Imagine lockout tagout for creating a safe electrical work boundary per NFPA 70E. Now, imagine that instead of a lockout tagout, they used air gapping to pull the breakers from the circuit. Air gapping is good. But the way they controlled the air gapping was by skill of the craft, not the same strict requirements and procedures as you have for lockout tagout. And it was implemented so terribly through skill of the craft, right, that the person was shocked, almost killed. He was hit by a 20 amp current. A half an amp could kill you. And the investigation uncovered that. Think of the benefits for future work. Okay, that's a quick one. Falling off a ladder. Same kind of things. We thought we'd fire the person because they stepped on the top rung, lost their balance. Turns out they were completely set up to fail by the organization. They were hired when they shouldn't have been. They were not qualified for the job, but they sort of waived that requirement because they didn't have enough people applying for the job. The person didn't know what they were doing. They didn't follow the requirements. There was no pre-job brief. They weren't wearing fall protection as required. So many things were violated, but they put an untrained person in the position to fail. And then lastly, so many people have been killed by chemical incidents. And I've had someone in my class whose son was killed by the exact same scenario. You tag out a system, but they went to the different location, not the one that was tagged because they were identical, right? And so what a tragedy. In this case, they only lost a finger from exposure to HF. People have died from a thimbleful of hydrofluoric acid on their body. So lots of incidents out there in all industries, chemical, oil, gas, nuclear, where it's a lockout tagout issue, where you tag one thing, you go to the wrong one, and all kinds of requirements in place for lockout tagout, and you still find that there's fatalities every year. So doing it right, doing in-depth analysis, doing the tracking and training, being proactive, all matters. And so here's what I want to tell you. Use the bow tie risk assessment model. It's going to help you focus on trending and proactive assessments. Leverage AI. It's here to stay. Everyone should be taking courses on AI, using it every day, and learning how to use it for data analysis, for deeper insights into what's really going on. Pattern identification, that's what it's good for, right? Looking at huge data sets, that's what it's really good for. It's not good for questioning people. Humans have to do the questioning. And you got to learn to use, we have done huge analyses. In one case, we had an analysis of a capital asset project that went 250 million over budget. There were people all over 8 states. We did it all sitting here at our individual desks, virtually on these virtual whiteboards, right? And of course, that combined with, so the ability to work on one board combined with AI, right? And not going down checklists and interviewing people one-on-one, all these things are antiquated. This is where it's going, all right? And if you really want to save your company money, you really want to become a valuable contributor to your company, the return on investment is on the proactive analysis of your defenses so that you prevent events from happening in the first place. That's where your money, your resources, your focus is better spent. That's what I wanted to tell you all and get across. And I leave you with this thought. Safety doesn't just mean that you follow your standard operating procedures and the OSHA requirements, right? For me, you got to stay a step ahead of the failures. And what do we want to do? I suggest you blend all these new technologies and proven risk models like the bow tie risk assessment model so that you can turn this gold mine of precursor events into significant insights if you do the proper coding, cost coding, training, analysis, all of that. And in the end, you're going to save lives. You're going to improve performance. There's going to be a significant return on investment for how you spend your time doing this type of work. And with that, I conclude my presentation and we'll open it up for questions. Preferred whiteboard applications for Matt. Okay, I chose a platform called Lucid, L-U-C-I-D, Lucid because Lucid went through the 18-month, $1 million federal process for getting FedRAMP approved, F-E-D-R-A-M-P, FedRAMP, which means Lucid Gov, Lucid Gov can be used in any sensitive application up to but not including top secret information. So it's going to protect all your information. So one license costs $450 a year, and I can invite 1,000 people and create 1,000 charts. It doesn't really, there's no limit, but it doesn't take many licenses per organization to do these virtual whiteboards. So that's been my preferred method. I have nothing to do with Lucid. I don't sell Lucid. You don't need another fancy root cause charting software because that's crazy. People are buying these branded root cause models. All they do is chart your results. And if it's garbage in, it's garbage out. You got to know what you're doing. So this is a free form. I have a template, but you can free form, just draw post-its and put the results of your analysis in these post-its. So you got to know what you're doing to work the way I work. Very good question. How about you, Sean? I know you have a question burning in your head there.
Okay, so you mentioned us as safety professionals, we really need to embrace AI. Is there a specific training course that you recommend, or all training courses?
Well, no, great question. So here's what I found out. If you want to learn multi-tier Pareto analysis with Python coding, you're going to use Microsoft Copilot, right? Up front, if you want to put in large amounts of reports and information to analyze, use ChatGPT. There's a $20 version. I use a $200 pro version. So there's multiple levels. There's a freebie, the 20, and the 200 version of ChatGPT. Okay. I also use the research version of Copilot. Again, Microsoft. If you're in the Microsoft ecosystem, you get Copilot. But there's the freebie, and then there's the 30-month upgrade that I use. And the researcher is the best thing it's got going there. And then lastly, when you're all done, if you want to write reports or emails or letters, Claude, right? Anthropic Claude is my favorite. It is by far better than Microsoft, better than Copilot, better than ChatGPT at writing beautiful reports that take everything you got and turn it into a logical report, and emails. I craft emails all the time with Claude. So you need to learn different applications of AI for different things. That's the reality, right? It's not one shoe fits all. So that's what I wanted to tell you. Yes, very good.
Excellent. Thank you very much.
Thank you, Rob. Yeah, that was an ambitious schedule there, and we have time to spare. That was great. I really appreciate that. I'll just give anyone else, if they wanted to type any question into the chat, or just feel free to unmute. One other thing that came to mind. So you mentioned it seems pretty straightforward with digesting something like raw data to make the Pareto charts. That seems pretty straightforward. What are you prompting or asking as far as when you're uploading something like procedures or training programs? Is there a certain question you pose to try and assess whether they're effective or not?
Yes, so you got to develop prompts, and prompting is an art in itself. And so some of my prompts are 5 pages long. No kidding. So to get what you want out of AI, you have to be very precise. So that's a really good question, Matt. But here's the trick. Ask AI what the prompt should be to accomplish what you want to accomplish. And AI will help you craft its own prompt that you can use as a prompt, right? But we've got some massive prompts that are very good. And basically we're asking it to say, compare the evidence, right? Here's everything that we know about the scenario. And now go get this data set of procedures that is already built into your client, to your company's AI. If you haven't uploaded all your procedures into AI, you should, and call it one data set. And say, compare everything that happened here against those requirements. Tell me where the requirements weren't met. Those are my defenses. And then there's a whole nother prompt to say, okay, now I want you to craft a line of inquiry question or set of questions for each of the defenses that were not followed. That's another lengthy prompt. And I mean, that's some of the stuff that I teach in class. So it is an art form in itself. And people think that it's asking it one question. It is not a one-liner. These are pages of prompts that'll get you the desired output, but it's fascinating once you get it working.
All right, I'll take it you had an extremely thorough presentation, so a lot of information to digest and take away from there.
Yeah, I hope the recording is made available, and you can watch it slowly if you want.
Oh, well, I appreciate that. I mean, it seems like we're right in line here with we just had an announcement over at Brookhaven, at least, that Department of Energy is shifting their focus from the HPI, from human performance improvement, to HOP, which is the human and organizational performance. So it's pulling a lot of blame away from the employee, and it's focusing on the fact that context drives behavior, and it's pretty much exactly in line with everything you've spoken to here. So
absolutely, we envelope human and organizational performance. In fact, the Oak Ridge manager, Susan Blackburn, has been my guest at several training sessions and a speaker for me. We blend perfectly with HOP. In fact, HOP is actually from the 1980s, from commercial nuclear, post 3 Mile Island. So I've been using HOP since the 80s. We're well versed in commercial nuclear on those principles.
All right. Well, thank you again, Rob. Really appreciate your time.
My pleasure. Thanks for the invitation. Have a great one, everyone.
Absolutely. Thanks for calling in, everyone.
You're welcome.
Thank you, Matt.